Hi everyone, it's Crazy. Someone asked on the Telegram group how to compute the fork plus weight plus exec exercise of the concept page. So let me show you how to do that. So let me create a new directory on the desktop. So let me create a new file called test.c. So let's read the requirements here. They asked us to write a program that executes this command in 5 different child processes, and those child processes should have to be created by the same process. And we need have to wait for a child to exist before creating a new child process. So here we need have to use the fork system call, wait system call, and exec VE system call. So let's just import the required libraries for fork, exec, and wait system calls. So let's first look on the fork system call. So man to fork. So it requires 2 libraries. So these 2 libraries are required for fork system call. So let's write them on RC file. And the second one is okay. So for exec also mount. So this requires the unistd.h library. So it already included. And the last one is wait. So wait requires 2 libraries. So this one is already included. So let's just add this one. Okay. So for a standard input output, let's just include the stdio library. .h. So let's create our main file with no arguments. And on success, it should have to return 0. Let's see what the requirement. Okay. First, we need to create a child processes. So to create a child process, we need to use the fork system call. So let's see the usage of fork system call. Man to fork. So it's a PID type. So it doesn't take any arguments. So let me just create first PID T the process ID, then let's create PID equals to fork with no arguments. So I think 5 different child processes we should have to create. So let's make 5 fork system calls. PID fork, PID fork, and then PID fork. So total of 5 processes are created. So for each process, the first thing that we need to check is if the process is created successfully or not. So let's see the return type of this fork statement. So on success, the PID return parent. On failure, it returns -1. So if it returns -1, we should have to print some error message to the standard output. So let's check that. If PID equal -1, then we should have to say error in creating a new child process, and then return 1, which is failure return. So if it's not PID, if the PID is not -1, so it means that it created a new process successfully. So let's check the PID of that process. So if the returned value is 0, so it's a child process, and if it's non-zero, it's a parent process or the father process. So let's check that. We can say if PID equal to 0, so do something, for example, execute, and then else we should have to wait for a child process to finish its execution before creating a new process here. So we should have to just wait for some status. So this is a syntax that you should have to follow in order to create a new process. But if you see here, we have to repeat these lines of code for every process that you have to create. So to avoid this, let's just include this all lines of code in a single function, and then call that function when it's required. So to do that, let's create a new function here. Let's just put its return type as void. Void fun or something you can say. So this fun function should have to receive the process ID. So it should have to receive the PID of the created new process. So let's do that. PIDT, you can say PID. So let's just implement that whole lines of code here. So if PID equal -1, let's print an error message. Error in creating a new child process, and then return. So if the PID value is 0, we know that it's a child process. So you have to implement our command execution here. And if it's not, we should have to wait for some status. Let's just make it as null, or you can just declare here an integer variable called something a, and put the address of a at a parameter to the wait system call. Okay, so that's all. Let's implement the execution of the command here. So let's see the man page of the exec. Man to exec. So the format is int excessive const car path name, and then car const parameters, and the third argument is the environment variable. So what we need is the path name, then the parameters, and then the environment. So we don't have to worry about the environment. We can just put this the third argument as null here. Okay, let's see the requirements here. ls-l/tmp. So we have to put this as an argument. You already know how to use the excessive system call in the examples that they give us on the concept page. So yeah, this one is a path, and these are the arguments, and this is the environment variable. For this case, it's just put it as null. So let's make our function like that. So, the first thing is that we have to create the path variable and then assign it to some all commands execute are the full path of the ls command is located at /bin/ls. So let me /bin/ls as a path, and then let me create the arguments as argv equals to so -l/tmp. So the first one is -l and then /tmp, and then let's finish it. But here on the definition, you can see that okay, let me show you something here. So here the MVP, the argv and MVP arrays must each include a null pointer at the end of the array. So let's just add a null pointer to them. So a null. So now we can call the excessive system call here. So excessive, then path, comma, argv, comma, and the environment variable we can put as null here. So let me just add always the first character array should have to be the path. That's argv of 0 should have to be path. So we call it. And let's see the return type of this function. The system call. So on success, it doesn't return anything, and on error, it returns -1. So we can just say here, if this returns -1, so what we need to have to do is print some error message. So pair error in creating, error in executing the command. So that's all here. So anything else is left, I think. So let's just delete this line of code here. And just call the fun function. So fun PID. So let me just call here also PID, and this PID. And lastly, so it's now complete. So okay, we just used null, so we should have to include the stdlib standard library, stdlib.h. So let's run our code. GCC this.c. So now it's wrong. Okay. I think we have made some mistake. Let me check that. pause. Okay, here I put -1, but -L should have to be. Let me run it again. Okay, now it runs 5 times. That's 1, 2, 3, 4, and 5. So now let's check whether this ls command runs under the child processes. We should have to make sure that. So for doing that, let's add some lines of code in it. So let's just print the process IDs of each created processes. So for that, let's just add this or val ID and just assign here val ID equals to get PID, and then let's pass that val ID to the fun function. So val ID and let's repeat this. So let's just modify our fun function. So let's add one argument here, a PID type. We just say val ID, same as what you declare in the main function. So okay, let's print the process IDs here. So for this, we can say printf I am child process and my ID is %d and then val ID. And for the parent also, let's print that. So after wait, we should have to printf I father and my ID is %d comma val ID. So let's see the output of the program here. Okay. Test.c printf. So let's see. So it doesn't print anything. Let's check vim. Okay, let's. If PID is 0, we should have to. Oh no. Let me just write this. Okay, printf and father IDs. Let's see that again. Okay. It's correct. My ID is %d, var ID. Okay. Let me add a new line here. I think this I should have to add to see the output clearly. So yes. Now you can see that first the child process is executed and the process ID of the child process is 4411. And the father and then the father process is executed, and the process ID of the father process is 4410, and then 441 child process that's next to this one, and it should have to be created by the same father process. So let's see that the father process is same 4410, and then the next child is 4413, and the father ID is same 4410, and then 4414, still 4410, and so on. So all processes are created by the same father process. So on the concept page, it says that each child should be created by the same process, the father. So we have just create a C file that executes the given command 5 times, and the child processes are all created by the same father process. And let's just add something and make the output quite so let's just add the process number for all the 5 processes. So here I can just add, this is process 1, child process 1, and then child process 2, and then child process 3, and then child process 4, and child process 5. So let's modify our fun function to receive that process number. So an int type, and you can say just num, and let's just print this also here. I am child, let's say I am child %d comma num, so that we can differentiate that each created child is executed its own ls-l/tmp command on the shell. So let's run the code again, test.c-o test. Then now you can see that the first one is child process 1, and the ID number for the child is 4472, and then 4473 for child 2 with the same father process ID here also, and child 3 4474, child 4, and child 5. So that's all about fork plus weight plus excessive exercise of the concept page. So thank you.